Capacitors. Here are your priming questions. What are some different ways of storing charges? What needs to be done in order to move those charges? What is the function of the dielectric? And what are some advantages and disadvantages of using capacitors? So capacitors themselves are just a form of storing electrical energy. And so the easiest and simplest capacitor is what we call a parallel plate design. So you have two metal plates that are parallel to each other and that they are separated by a certain distance. When you use a battery, the battery will actually move charges from one of the plates to the other. So the battery does work on the plates by moving these charges. And when that happens, we can see that one of the plates becomes positive and the other plate becomes negative. This produces a potential, so there's a voltage here, and the charges will continue to move until the voltage between these two plates is equal to the voltage of the battery. And so if you want to store a greater charge in a capacitor, you can increase the voltage, and you can also decrease the distance between these two parallel plates. If you think of the electrostatic force between them, the force will be greater the closer the plates are together. So you bring them closer together, you can store a greater charge. You increase the voltage, you can also increase the charge. But what do you think might happen if you get the voltage too high or if you put the plates too close together? We'll talk about that in class. So this is another way of looking at it. We again have our parallel plates, so our plates are vertical in this case. We have the dielectric now, so this is where I want to talk about the dielectric, that is in between the two plates. The dielectric is a very specific type of insulator, and so it does not allow charges to pass through easily, but the dielectric allows electric fields to pass through easily. And not only that, but the material itself that the dielectric is made out of, even though it's an insulator, it can be polarized. And so you can see that it has negative, positive, negative, positive. And so what this does is it aligns itself to the electric field, and in some cases, it can actually increase the strength of a capacitor and how much it can hold. Now, if you look at these blue lines are the electric field lines. And so in class, we'll talk about which side you think is the positive and which side you think is the negative. All right. Now for some of the applications for capacitors. Very simple idea, storing charge. But the applications for this are very wide and can be used in a lot of different things. These are some common examples of the capacitors that you might find in a computer or in an electrical device. These are cylindrical capacitors, and what they've done to make these is they've taken the parallel plates, they've essentially made those plates into foil, and they've put a piece of paper in between the two plates as the dielectric, and they've rolled it up into a cylinder, and then they attach the leads onto those foil pages, essentially. Now, some of the applications. If you have a camera that has a flash, or even if you've used a disposable camera that has a flash, if you remember back to film, that flash requires a tremendous amount of energy to be able to give the bright flash. The way that the cameras are designed to be able to give that flash enough energy is through the use of a capacitor. So every camera will have a battery that has that usually in the side over here, but that battery doesn't have the right voltage and it can't release enough energy quickly enough for the flash. And so this battery will then, if you don't need to use a flash, it will use one of these capacitors. It'll charge up the capacitor, and then once the capacitor has received enough energy, then when you click on the shutter, there are wires from the capacitor that lead to the flash, and it will be able to release all of its energy very, very quickly, giving you the really bright flash. In some cases, you can actually hear that capacitor charging up. You can hear it as a bit of a whine. There's more electrical stuff that deals with that, but that is what you're hearing for the capacitor for the flash. For your refrigerators and for motors and for industrial and commercial applications, oftentimes we will have these heavy-duty motors that are connected to a strong load. And so when you want to start up the motor, if you just apply energy to these leads without a capacitor, this motor won't be able to run. And so what happens is, if you want it to be able to start up, these motors use what's called a starting capacitor, which usually you see as an extra bump on the round cylinder for the motor. And what that does is, when you first turn on this motor, the energy actually goes to the capacitor, charges the capacitor, and then it sends all of that into the motor, causing it to have a really strong initial rotation, which allows the motor to begin rotating. And once it begins rotating, it doesn't take too much more work in order for it to keep rotating. This is also how a lot of refrigerators and freezers work with their compressors. The compressors are always under a load, it's under pressure, and so you use a starting capacitor to get it started, and then it can keep going. Capacitors are also used in power supplies for your computer, for your laptop, for your device. These capacitors help to smooth out the voltage. It prevents there from being spikes or voltage getting too low. It stabilizes out the voltage, because all of our computers and devices need a really stable voltage in order to be able to work properly. And these capacitors help to store additional charge, so it sort of cuts off that top part. But it can also, when the voltage gets too low, it can release some energy, and it helps to stabilize it out. So those are just some of the applications that we use for capacitors.